So, why is Gini impurity preferred over entropy? Question is very intriguing in nature. So, first of all, we need to understand what is the Gini impurity and what is the entropy and how do they work. So, imagine you have a data set of some few rows. For example, I take two-dimension data set. So, these are the two features x1 and x2, and this is the label y. And this label is one non-random variable that has it can only take two possible classes 1 1 0 1 0 anything like this. Now, if we're trying to build a decision tree model based on this, so how will it look graphically and how will it look like in a ML format? So, in a two-dimensional data set, let for these features, these pair of features, this is the class label one. I am denoting x as one and zero as zero. Very cool. Uh, this is one class, this is one class, and this is some other class. So you can see, if we, I should actually use some more features here. So as you can see, uh, I have a few intermixing of classes, so it's not a problem. Now, this is the class 0, and these are the class 1, and these are the features, x1 and x2. Now, when we build a descent tree model, what will it do? It will take a particular feature. If that, since it will take a particular feature, and this feature will be taken such that after the split, for example, if I took x2 as a feature, that is, if x2 has a value greater than, for example, here it is 7. If x2 has a value greater than 7, then split the data set. Now, if x2 greater than 7, then one after the two nodes formed will contain the two data points, two type of data points. This will be if this node is n1 and this node is n2. Then this region will comprise n1 and this region will comprise n2. For example. Okay. Now, in n1 again a set of features will be taken. For example, this time if I took x1 less than 5, so based on x1 less than 5, again two regions will be formed. Let this be n1 dash and let this one be n1 double dash, n1 dash and n1 double dash. So this is how the splitting goes on and on, unless and you can see in each split there is a rectangular being formed, and the rectangle becomes more pure at least. What do I mean more pure? That if there was impurity, that is, if the intermixing of too many classes altogether, after the split, it became pure. Then there was only one type, either all crosses or either all zeros. So this is what it means by the node becomes purer and purer. And as you can see, the leaf nodes where the splitting stops will be the most purest node. That is, the impurity will be zero. So this is how the decision tree works. Now, what is the role of Gini impurity and entropy? So Gini impurity and entropy both are used to measure the entropy, the level of disorderness, the level of disorderness. For each measure the level of disorderness in a particular node. That is, after a particular state, it has this type of data points, then what is the level of disorderness, etc. So Gini impurity uses the formula 1 minus summation pi square over 1 to all the classes possible. What is pi? Probability of data point to lie in a particular class I. Probability to lie in class I. What this means, for example, if we take n1 dash node and it has a data set like this, x, 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 0, 0. So probability of class 1 is how much? 3, total number of observations, but sorry, number of favorable outcomes 3, total number of outcomes 5. And probability of 0 to occur in this class is how much? 2 by 5. So the impurity will be how much? 1 minus 3 by 5 whole square plus 2 by 5 whole square. Since there are only two possible classes, 0 and 1 in the data set. This is what I mean. So this is the Gini impurity formula, and similarly, we have an entropy formula, which is equal to uh, minus pi into log pi summation over all the classes. And this log basis 2. You can remember it, it's not too much useful. Entropy minus pi into log pi base 2. And this one is essentially square. So as you can see, if we calculate the Gini impurity, we only need to calculate the pi. But nevertheless, if we calculate entropy, we need to calculate the log value also. And as you can know, the log uses characteristic and mantissa, and that is like too much computationally expensive task. So since genuine impurity is much easier to calculate, much easier and less computationally expensive than entropy, that's why it's preferred over entropy. Just a simple reason, it's computationally less expensive.